Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see two interesting concepts in this particular video. One is RF communication link, another one is code hopping. In previous videos we have already seen lot of interesting concepts in short range wireless communication, and today we will start with RF communication link. Whenever we say RF communication link, it is nothing but a basic transfer of information or transfer of a message from a transmitter to a receiver. So when it comes to transmitter, we know that a transmitter is the one which transmits the original message, and the receiver will receive that original message and it will reconstruct that message at the receiving end, right? And source data is the original message signal that has been transmitted from the transmitter, right? This source data can be either an analog data or it can be a digital data. And when it comes to short range wireless devices, we have a lot of short range devices like motion detector, intrusion detector, alarm system, gas detector. You have lot of those detectors where everything is based upon a same principle. For example, if you take an intrusion detector, what intrusion detector will do, it will just send a control signal. It will send a signal to the central station whenever it finds any particular motion. It detects any particular motion, right? Or any particular intruder, right? So it will be in the same state, right? It will be in no motion state. That is, it will not detect any particular motion until or unless any person crosses that particular detector, right? And only at that particular time, whenever it detects that particular motion, it will send that signal. The same thing is applicable even for fire detector, right? What it will do is it will create an alarm whenever there is a fire. So until there is fire, there is no fire, right? You will not get any alarms, right? So once it detects that particular signal, right? Once it detects that particular event, it sends that signal to the central station, which means the data that is going to transmitted for these short range devices requires only very low bandwidth. It requires very low bandwidth because it is just going to send a particular information. That is, it is going to just send change of state information, right? So it requires only very low bandwidth for short range devices. Even though it requires very low bandwidth, but the information that has to be transmitted is very sensitive. It is very, very important. That is, say for example, you have a fire detector, right? So what it has to do, it has to detect the fire, and only if there is fire, it has to send the signal to the central station to create an alarm, correct? Right? If in case, if it sends any false detection, that is, without fire, if it detects, if it sends a signal to the central station, an alarm will be created, correct? It will create a confusion. Similarly, a motion detector, right? So sending this information, even though it is requires very low bandwidth, the information of this particular devices is very, very important. That is, the receiver has to receive the correct information. It should not get very false information from the transmitter. So to avoid the false information, right, or to avoid the errors during transmission, what we have to do is we have to encode that particular message. What is encode? Encoding is where we will use encoder in different forms, but right now here what we are doing is we are encoding the data so that we are making the data very secure form, right? So that if any intruder gets the message, or due to noise, it will not correct the original signal. So the original message signal has to be encoded in such a way that it is protected from the noise or any particular hacking, right? So that is the process of encoder. Once a encoder, the message is safe so that the receiver will not get any false information. So the information will be received correctly, and even though if there is any particular error, if we encode that particular message signal, right, it can be detected. We will have some error detection technique to detect if there is an error or not, right? So that is the purpose of encoder. So the original message has to be encoded so that the message will become very secure. And another important thing is we need a modulator and an amplifier. What is a modulator? We already know that whenever we need to transmit any particular message signal, right? Any particular message signal to a longer distance, what we have to do is we have to add a carrier signal, right? We know that message signal, any analog message signal, it will be a low frequency signal. Technically speaking, it will be a low frequency signal. We cannot make the low frequency signal to travel for a very longer distance. Say for example, if this is your message signal, we need to make this signal to travel to a very longer distance. So what you will do is we will add carrier signal, that is a high frequency carrier signal, right? So that the original message signal can be carried to a very longer distance. This process is called as modulation, and it will be done by modulator, right? And also like we can able to amplify the signal whenever without modulation, if you need to amplify the signal which is coming here, we can also amplify it by using an amplifier, right? And after doing modulation, amplification and all those things, that signal can be transmitted through the communication link using an antenna, right? And now this signal will be received in the receiver. Now the receiver will perform all this operation of the transmitter, but it will be done in the receiving order. It will be done in the reverse order, right? So that is from down conversion, detection, decoder and reconstruction of data. The same process which is done in the transmitting side, but it will be done in the reverse order. That is, you can see RF down converter, that is the received signal, that is we have already amplified the signal, right? And we have used modulator and amplifier. So here what we have done is, after receiving the signal, right, if we have used amplifier, we have to convert that signal to the original form, right? So it will be down converted to the previous form, before amplification form, right? And then it is detected. What is detected? Detector will act as a demodulator here, right? So it will detect the original signal, right? So that is, in modulator what we will do, we will add this message signal and the carrier signal, whereas in detector here what we are going to do is, it's going to act as a demodulator, where it will separate this message signal and carrier signal, and it will get only the message signal, right? And here encoding, I've already said what is encoding, right? The process during the transmitting side, what you would have done is you would have added some bits. Say for example, if you are transmitting a digital data, right? If you are transmitting 0, 1, 1, you would have added extra bit, right? I'll explain that while explaining encoder separately, right? And you'll add an extra bit to encode this particular data, and this extra bit will be removed here in this decoder. It will do the inverse operation of the encoder, right? And then the original data will be reconstructed, right? So this is the complete operation of an RF communication link, right? Whereas as I said, the source data, it can be a motion detector, alarm system, or even a panic button, right? So in all these systems, right, it will send a signal only if there is a change of state, right? If you press the button, it will send the signal, right? If there is a fire, it will detect and it will send the alarm, and if there is any particular motion, it will detect, right? So all those are intrusion detection system, where after detecting that particular motion, it will send it to the receiver, and it will be connected to the alarm system, right, through the control panel, and by receiving this signal, the alarm will be alarmed, right? So everyone will hear the alarm, right? So as I said, this system is very simple and requires very low bandwidth, but it has to be very secure, right? So whatever I said, that is what I explained here. You can see any security system, infrared motion detector, or push button transmitter, or wireless smoke detector, any alarm systems, gas detectors, water detectors, everything requires very low bandwidth. Only the change of state is going to happen. That is the information which is going to be transmitted, right? But to transmit this message, right, the receiver has to receive this particular message very accurately. Even not a small amount of noise or a random noise should not be communicated wrongly. The receiver should not get a false information because of noise, right? So to avoid this false alarm, right, to avoid this unwanted on and off situation of a transmitter, right, what we can do is we can encode the original message, right? That encoding is done by the encoder. So the purpose of encoder here is it will group the bits and it will assemble into frames, and it makes sure that the receiver will not receive any false information. So it will be secured it will be transmitted very securely. And you have certain message frame for this particular encoder. You can see you have preamble, address, data, and parity, where this is your original data, but this original data is surrounded by all this information, where preamble is the one which tells the receiver that there is transmission, like you're going to receive a particular message. It will intimate the receiver that it is going to receive that particular message. That is preamble. You can see here preamble, which conditions the receiver for the transfer of information and tells when the message begins. Right, the message begins will be intimated by this preamble. And the next field is address bit, where in the address bit it gives you the information. It will be a unique address. It will tell you who transmit the data, where the data has to be transmitted, right? The source address, destination address, everything will be indicated by this particular field. And this particular field is data, where you will have the original data that has to be transmitted. And this is very important, which is parity bit, which is used to detect errors, right? That is, for example, if you're going to transmit this particular message, right, 111, right? So what it will do is, during encoding process, the parity bit, it will add one extra one, so that, say for example, if it is going to follow even parity, the transmitter and receiver will know that they are going to transmit and receive message only in even parity, right? So now this message is transmitted. This is the original message, and this is parity bit. So now it transmits in even parity. Now the receiver receives this message. Say for example, if there is any particular distortion, or if there is any particular error that has happened, right? Then instead of this 111, if the message is converted to 011, right? Apart from that, everything is received as same, right? Now the receiver, what it will do is, it will once again check the parity of the information which is received, right? So now it understands why there is only 3 ones, which is of odd parity. But the receiver knows that the transmitter would have sent only with even parity, because it is the key between the transmitter and receiver. They will transmit only the message in the even parity bit. Now receiver understands that it is a odd parity, so it ensures that there is some sort of an error. So what it will do is, it will discard this particular message and send an information to the transmitter to retransmit that particular message, right? So this is where error bits is very, very important. Parity bits plays a very vital role, right? And which essentially makes the receiver understand whether the message is correct or not, right? And this is about RF communication link. And now we will see very important concept of code hopping. What is code hopping? Code hopping is another security technique. We just saw about encoding a particular message, right? Similar to that, we have something called code hopping. Code hopping is security technique which is used in wireless communication system to prevent the unauthorized access or eavesdropping, right? And this code hopping is used in various transmitters and receivers, where this code hopping technique, what it will do is, it will change its codes. That is, the transmitter which is using the code hopping technique, it will change its frequency for every new transmission. And this particular technique can also be called as code rotation, code hopping, or rolling code addressing, right? And the very important technique, the very interesting concept of spread spectrum, which is frequency hopping, it also comes under this code hopping technique. In code hopping system, both transmitter and receiver changes its frequency, right? Multiple times. At multiple times it will change its operating frequency. And this changing of frequency, right? Changing of frequency will be done by using a particular sequence, pseudo random sequence, right? Pseudo random sequence, so that no intrusion, no intruders can able to understand what is the code they are transmitting or what is the code that is used. No one can hack the information. That's because it will periodically changes its codes, right, based upon the pseudo random sequence, and it uses a particular algorithm which is pseudo random algorithm, right? This pseudo random algorithms randomly create codes so that it cannot be predicted by any particular intruders, right? And because of this code hopping can provide two important techniques in communication. One is enhanced security, another one is synchronization. What is enhanced security? Enhanced security is by rapidly changing the frequencies, right? It will make the system more secure. It is more resilient against interference, jamming, and eavesdropping attempts. And another important technique is synchronization. That is, synchronization is achieved using code hopping, because both transmitter and receiver stay synchronized to the hopping sequence. So whenever transmitter changes its hopping sequence, the receiver will also change its receiving sequence, the coding sequence, because it follows the same algorithm, right? So both transmitter and receiver will be synchronized, right? If it is not synchronized, if there is no proper synchronization, then the communication will not be very effective, right? And very important applications of this code hopping is remote keyless entry systems for cars, garage door openers, wireless alarm systems, secure wireless communication protocols, right? And today what we have seen is, we have seen very interesting concept in short range communication. That is, we have seen RF communication link and code hopping. I believe this video will be very useful for you. Thank you, my dear students.